All right, this is 11.2. This is simplifying radicals day 2 because now you are doing operations with the radicals. You are actually going to add, subtract, multiply, not divide, the square root expressions. But today's operations are actually pretty easy because if you think of the radicals instead as variables, this is a piece of cake. So let's take a look at example A. Like if you look at example A and you see that we have 7 times the square root of 5. Well, let's think of the square root of 5 as x. That means that this is actually like 7x. Now, I have minus the square root of 11. That is not the same thing as the square root of 5. If I think of the square root of 11 as the variable y, I can write that as minus y. And then I have plus 4 times the square root of 5. Well, the square root of 5 I'm showing as x for right now. Now, if I take a look at that, if I think of the square root of 5 and the square root of 5 as being the same variable and the square root of 11 being something totally different, how would you solve this with variables? Well, you'd take the 7x and you'd add the 4x. Your answer would be 11x minus y because you can't simplify the x's and the y's. This answer is the same thing, but instead of the x's and instead of the y's, our answer is 11 times the square root of 5 minus the square root of 11. I can actually add the square root of, or 7 times the square root of 5 plus 4 times the square root of 5. I can combine those to get 11 times the square root of 5, but I can't simplify minus the square root of 11. So if you think of these as like terms, that's when you can combine them or add them or subtract them. Now in letter B, the problem is I have 2 times the square root of 2 minus the square root of 18. Well, the square root of 2 and the square root of 18 are not the same radical, so I can't combine those right now. I can't combine them unless they have the exact same radical. But do you notice that the square root of 18 can be divided by 2? Oh, I'm sorry, that doesn't matter. It only matters if it can divide by any of these numbers. And it can divide by 9 and 2. So 18 is the same thing as 9 times 2, and I can square root 9. And this becomes 2 times the square root of 2 minus 3 times the square root of 2, because the square root of 9 is how I got 3, and my 2 is left on the inside of the radical. Now they do have the same radical symbol. So now I can combine these like terms. I have 2 times the square root of 2 minus 3 times the square root of 2. It's actually negative 1 times the square root of 2. They are just like terms as soon as they have the same radical expression. So let's take a look at it. So I have 3 times the square root of 11 plus 2 times the square root of 44. They're not the same right now, but 44 can be divided by one of my perfect squares. It's 11 times 4. Well, that means this is 3 times the square root of 11. Now, this is 2. Now, the square root of 11 I can't solve, but the square root of 4 I can. And the square root of 4 would be 2, but I already have a 2 out there. What I'm going to do is I'm actually going to multiply them all together. Isn't this all just multiplication anyway? 2 times the square root of 11 times the square root of 4. So now it becomes 2 times 2 times the square root of 11, which is 4 times the square root of 11. Now they have the same radical, and now I can add them. 7 times the square root of 11. Answer. Done. This other example is pretty much from simplifying, and we're going to skip that because we're on operations right now. So that's how we add and subtract. Adding and subtracting, we're just combining like terms. When we're multiplying this like it's a variable still. But you got to remember your multiplication of binomial skills, and we have to FOIL this first, outside, inside, last. Let me copy it down. 3 minus the square root of 3. Okay, so I'm going to start off by taking 4 times 3. Yes, that's right. You heard me. 4 times 3, 12. Now, minus 4 times the square root of 3. Now, 4 is outside the radical. 3 is inside the radical. So this is just minus 4 times the square root of 3. Outside the radical, inside the radical. Ooh, hit something weird, sorry. Okay, now I'm going to distribute the square root of 3. The square root of 3 times 3 outside the radical, and it's positive. 3 outside and 3 inside. And then I'm going to take So positive and then negative, so it's minus. Now I'm going to take the square root of 3 times the square root of 3. Do you remember what you get when you take the square root of 3 times itself, the square root of 3? You end up just back with what's inside the radical. The reason that this works is because when you multiply those back together, the square root of 3 times the square root of 3, you get the square root of 9, which is 3. Now, do you see the problem we have created? I have 12 minus 4 times the square root of 3 plus 3 times the square root of 3. Hey, look, those have the same radical. Let's combine them. I have negative 4 plus 3, so what, negative square root of 3? And I have 12 minus 3. That's your final answer. You can put a 1 in front of the square root of 3, but you absolutely do not have to. But that would be your final answer. We added our numbers together, 12 minus 3 to get 9. Negative 4 times the square root of 3 plus positive 3 times the square root of 3 is how we got our negative 1. So let's try that again. So when we distribute, so we have one monomial, we're just going to distribute this to all of it. So I'm taking the square root of 7 times 2 times the square root of 7. Well, remember what the square root of 7 times the square root of 7 is. It's just 7. So 7 times 2, that would be 14. And the square root of 7 times the square root of 3, those are both under the radical. So I can combine them, 21. And it is plus the square root of 21. That's your final answer. Now, remember, if I have an expression squared, that means 3 times the square root of 5 plus 7 times 3 times the square root of 5 plus 7. It's the same binomial times itself, so now we need to have some fun with distributing. All right, think about this one. 3 times the square root of 5 times 3 times the square root of 5. Well, that gives me 9 times the square root of 5 times the square root of 5. Hey, that's 5. This times this equals 45 because there's your 9 and there's your 5. 9 times 5. Now let's do the other ones. Plus 3 times the square root of 5 times a 7 on the outside means I'm going to multiply my numbers. 21 plus the square root of 5. And then another 21 times the square root of 5. And then plus 49 because that's 7 times 7. Well, hey, look, those are both square roots of 5. That's 42 times the square root of 5. And then 45 plus 49 is 94. It is pretty to put the number in front of the radical, but there you go. Kind of crazy. All right, and let's take a look at this one. 16 minus 2 times the square root of 6 plus 8 times the square root of 6 and then minus 6 gives us 10 plus 6 times the square root of 6. Done and done, and those are your like terms. And here is the end of operations.